Uh, Now, gentlemen, we will start our third module in the CCSB. As you know, that the cloud certified security professional, it is divided into modules. There are 6 modules. We covered the module 1, 2, and today we will cover the third module. Third module is the cloud platform and infrastructure security. Then this means that we will start to speak about the infrastructure and the platform security. We will speak about firewalls, we will speak about VPN, we will speak about a lot of other issues. And this is a very interesting diagram, which it will show you the components or high-level design of the components of any cloud service provider infrastructure and services. As you can see, and of course, sorry?
I think you're not sharing the screen.
I'm not sharing the screen. Oh, you are right. Okay, I'm sorry.
Yeah, we can see it now.
Excellent. Okay, and thank you, Brim. This diagram it gives you a very high level view for the components of any cloud service provider. First of all, you will find the physical hardware and environment. Of course, when we say the environment, he means the data center. You must have, of course, a data center. Let me try to share my screen here. When we start to speak about environment and physical equipments, this consists of the data center. Of course, as we mentioned, by the end of the day, the cloud service provider, it's a data center. Then you have the data center, and the data center, what are the components which you will find in the data center? Of course, it will be very important, the space, which you have it to host all the devices, power, AC, cooling. Cooling, it's AC, okay. And other facilities. It may be generators and so on. Also, you will find the cabling. Then you will come to the network devices. It may be switches, routers, and so on. Then you create the network where all these devices are connected together. Then you will find the computing devices. And when we are saying computing, usually it will be physical and virtual servers. When we will see computing, this it will cover the processors, memory, storage. Storage, it will be a different thing. Okay. And finally, of course, you will have the hypervisor, which it will change from physical into virtual. These are the quick diagram for these features. It is very important to understand how it will work together and how we will integrate together to create or to provide you the service which you are looking for. Now let's have another quick view on the external or the redundancy, the physical environment. This is the physical environment which we mentioned before, and as I mentioned to you that this, of course, it will be what the data center. This it will be the data center. This is very important. Without the data center, you will not have anything. And of course, here, gentlemen, in the physical environment or physical data center, it is very, very important to have redundancy. It is very important to have redundancy because there is no room, there is no possibility that the service it will be down, and this is normal. You may have internet connection with one cloud service provider. The internet connection is down. When if it's down, then the user will not be able to access the data and the application. Then this means that you must have two different connections from two different cloud service provider. If the first one is down, then you can utilize the second connection by the user. Then they can reach to their data and their application. Also, the redundancy, it is not only for the facilities and the external services. No, it can be for the internal services as well. Because, for example, you know that when we will have a data center and a network, for example, we may have something called a core switch. This core switch, this is considered as the center or the centralized location where it's connecting everything. You have here maybe access switches, and here you have a server switch, here you have servers, here you have desktops, and all these are connected here. Then, as you can see, if there is any desktop here want to reach to the server, he should reach through the core switch. The core switch, if it's failed, then this means that the whole network, it will be down and users will not be able to reach to their data or applications. Then this means that it is very important to have two core switches, and these two core switches, it should work together, active or active standby. It depends upon the way where you will configure the cluster or the redundancy configuration. Then redundancy, it is very important to have internal redundancy and external redundancy. External redundancy, let's go through the external redundancy in more detail. Power lines, it is very important because data center without power does not mean anything. Then you must have two sources of power from separate entities. One of the challenges, gentlemen, which you can face that in some countries, you may have only one source for power in your area. You have only one source of power in your, maybe not area, maybe country even. As in Saudi Arabia, for example, we have the it's called Skiko. Skiko, this is a company which is responsible for providing the services for power. Then it is a single company and it has its own infrastructure. When if it has single infrastructure, then in your area, you may have one connection only. But the power lines, it can be substituted by generator. Then if you have power source, this will be great. Otherwise, if you have a generator, then again, this it will be workable and we don't have any problem. This it will be accepted as well. Then you have to understand that the power, it can be a generator as well. Generator, it will can work. And as we mentioned, power substations and generators, generators fuel tanks. Generator fuel tanks, I remember, gentlemen, first time I read these generator fuel tanks, I loved. And what if I don't have a generator? Then of course I have a tank for the generator. But I remembered one of my scenarios, my life scenarios in my work. we had power generator and it's up and running and it's ready for the customer and everything is going fine. But unfortunately, when the network is down, we found, I mean, when the power from Skiko was down, we found that the data center is down. And when we checked what was the problem, we found that the generator tank does not have any kerosene, that it was not filled. Then this it will be very important. These tasks are very important. This is considered as a simple task, but as you can see, if the generator it's not the generator tank it's not full, this means that you will be in a problem and your data center it will be down. Network circuits. Usually, when we are saying network circuits here, we mention or we mean the external network connections. It may be internet connections, it may be other connections for whatever any thing or whatever. But these network circuits, take care they are external. Then don't be confused with the internal network. Internal network, we will discuss the internal later, but this is external. Maybe internet. When in the internet, if I have a connection with cloud service, I mean internet service provider 1 and internet service provider 2. This is very important to provide these two connectivity for me. Building access points. You must have multiple access points when you will be able to access the building. And of course, cooling and sharing infrastructure. This is very important. The cooling infrastructure is very important besides the power and all this stuff. And it should be, again, redundant. This should be redundant. Don't forget that we always speak about redundancy. These components should be redundant. Cooling, it is very important. If the AC is down and user still accessing the data, then this means that when in some time the temperature it increased and it can burn the whole machine. Okay. Now we provide the redundancy for your internal network. That's great. But what about the internal network? We provide it for external, and we want now to discuss it for the internal network. For the internal network power distribution units, these power distribution units, for those people who are not familiar with data centers, it will be, gentlemen, the power source, and you will have cabinets. You will have different cabinets. And these cabinets, it will have a power entry. It have a power entry here. And this power entry, it will be divided into a power outlet where the machines, it will be connected to these power outlets. When the power, it should be connected like that. It should not be the power distribution unit. This called power distribution unit. And for example, you have here the cabinet, you have here the rack, and here the power like that. You have a server here. When the server power, this the outlet of the power, and this it's connected to the power source. Of course, this power source, it must be redundant. This power source must be redundant because if the power source is redundant, if the power source for any reason is defective or it's spoiled, then this means that the whole servers, it will be down. Then you must have a power server for each a power, I mean, distribution unit for dual power distribution unit, dual, two of it, yeah, one here and one there. And of course, you must have redundant power supply for each device. One is connected here and another one connected here. The other thing, power feeds to racks. It is very important to have a power feeds to rack. Two, it's not one. One, it will not be enough. If one, it not be enough. But as we mentioned, if it's in single source, then it's okay. If you will have here a generator or a generator, it can be connected here. It depends upon the design of the data center design, redundancy. Cooling chillers and units. It's important when networking. Here we are speaking about the internal networking. Here we are speaking about the internal networking. Do you remember when we said that you have here core switches and you have here access switches, here you have workstations, here you have the servers. Then if you have the user who is sitting over the internet, he will come like that to access the server. The network, internal network here, it should be redundant. The storage, I mean the switches, the core switches, the routers, and so on. Also, the storage, it should be redundant. When we are saying storage, it should be redundant, it does not mean that you have multiple storage, but you can have a storage and it's configured with RAID 5 or maybe RAID 6 or RAID 10. This it will be great and it will be acceptable as well. And if you will have a different storage as active and standby, this it will be better and it will provide highest availability. Physical access points, again, these physical access points for the data center. And when we are saying physical access points, we mean that the access points for the data center. When you have a data center, how many access points or doors or entries you have? It is not recommended to have single one. It is recommended to have more than one access point. It is very important here to understand the concept in general, but details, it's not important at all because CCSP, they will not test you for physical environment redundancy. This is not their task at all. Then just you have to understand the redundancy. You have to understand from the external, we have to provide power connectivity, we have to provide network circuits, we have to provide AC resources, power resources, AC resources, and so on. And from the internal, for the network, for distribution, power distribution units, for the cabling, for storage, for network devices, and so on. This is the physical environment redundancy for any data center. And of course, gentlemen, this is for the data center in general. I'm not speaking here about the cloud, but if you are familiar or if you are working with the cloud in a data center, you know that this is the standard, the normal standard for any network. Even it may be your internal network or in the organization or the data center in your organization. Okay. Also, we have another important component, which is the network and communication. Network and the communication. It is very important here, gentlemen, to understand again that we have two different types of networks, the traditional one and a new techniques which is called software-defined network. It is called software-defined network. You will find in some situation we call it SDN. And SDN, you will hear this SDN a lot. The SDN. What is the SDN? SDN, it is the software-defined network. What is the difference between the two networks? What is the difference between the networking hardware and the software-defined network? Networking hardware, this is a traditional network. This is our traditional network. You have a core switch, and this core switch is connected with access switches. Here there may be workstations, and here there may be other switch where the servers are connected, and so on. This is our traditional network. In the software-defined network, it will be, and of course, in the configuration here, it will make different. For example, I can make this switch, some of these workstations here and there in one group, or which we call it VLAN, and we define it as financial, or it may be IT, or whatever. In the software-defined networking, with all the configuration, it will be done on the level of a software. All the configuration will be done on the level of a software. It is not only a physical devices, it will be software devices. When the configuration, it will not be done on the level of the hardware, on the switch itself. It can be done on a centralized management workstation, and this will be downloaded into the switches. There is a common question, you will find it in security in general, that the SDN, it is preferred in as a security point of view. Why? Because in the software-defined network, we will split the data traffic from the management traffic. What is data traffic and management traffic? Suppose that you are, let me share my desktop. Suppose that, as we mentioned, that you have here the core switch, you have here access switch, and here you have another access switch. Here you have server switch, and these switches are connected together. Here you have desktops. Here you have firewall. You have router, and you have here user. If the user want to access the server, he can go like that. If it's internal network, he can go like that. If I want to manage one of these switches, suppose that this is the administrator, he is sitting here, and I want to manage one of these devices, then I have to use the connection like that. Then I will open telnet or SFT or whatever, any secure protocol to connect. Then you can see that the network, it has the data traffic. The data traffic, this is the user traffic, and management traffic. And management traffic, this is the traffic for managing the devices and configuration devices. This is not secure. This is not secure. Why? Because we have the management traffic is very important, because it may have some username passwords, it may have some configuration. Then if there is any reconnaissance and this traffic it's captured, the hacker, he can draw a blueprint for your network. Then it is highly recommended that this data, it will be split. And we will see later that we are splitting this data by some other techniques. We will discuss it in the next few slides. Then the SDN, or the software-defined network, one of the main features that we are splitting the management traffic and the data traffic. Both of them are moving on a different path or a different channel. Then they are not integrated together, and this, it will provide more secure approach for us. And this is one of the really recommended techniques from security point of view. Okay. Yes, Prem.
So, sir, on the SDN, as you were saying that it distinguishes actually the management traffic and the data traffic. So the management traffic is just to, I mean to say, I mean to say, if you could just again re-explain the difference between the management traffic and the data traffic, it would be good.
Data traffic, this is the normal traffic, user traffic, accessing application, access data, and so on. Management traffic, this is traffic for managing the network devices, configuring network devices, added devices, whatever, configuration of the devices.
Okay.
Okay.
So, sir, on the SDN again, I think some books are talking about the 3 layers. That is the data layer, control layer.
Please forget about all these things. Even if you are expecting one of these questions in emergency technologies, it will be 1 or 2 questions. You will not go through SDN. SDN, it is a complicated issue. It is 5 years, 5 days course. Then please don't waste your time.
Okay.
Don't waste your time. You will have a lot of information. You will confuse yourself, and unfortunately, you may fail. SDN, it is some way of logical networks, and even if you will open the books, you will find this is we are speaking about. It is some way of logical networks where the configuration is done through the software. It's not as physical as before, and it is recommended because the management traffic, it is isolated from the user traffic. Then, if you will go in more details, Can you find the question in exam about this? You may be, yes, as emergence techniques. But as I told you, emergent techniques, it will be 2 or 3 questions. We are not expecting too much questions. Then I don't want you to confuse yourself. And by the end of the day, you will not reach to a level which you can say that you are understanding the SDN as well.
Okay.
The other module now we will speak about it. It is the computing, and usually when we are say computing, we mean the processor and memory. Processor and memory. Usually with the cloud service provider, when we are saying computing, it's processor and memory. Gentlemen, these definitions are very important. These definitions are very, very, very important. You have to understand them very well. Because this, it will help you in a lot to answer a lot of questions. Reservations, limits, shares, and these are three definitions. Number 1, the reservations. What is the reservation? What is the reservation? Reservation, this is the minimum sorry, I will, for some reasons, the share it was terminated. The reservation, this is the minimum resources guaranteed by the cloud service provider for the cloud service user. Okay? This is the minimum resources guaranteed to the cloud service provider by the cloud service provider to cloud service user. For example, I leased a server 5 processor, 32 GB RAM, 20 terabyte space. But as you know, we are using what? We are using shared resources. We are using shared resources. These resources, it may not be guaranteed that you receive it at every time. The memory may be one moment it will be 16 because there is another tenant which is using high memory and it's considered as high priority or whatever. Then and of course, if you will have this information and this information, I mean these resources, and these resources are very important for your application, and your application will not working without these resources, then what will happen? This means that your network, it may be down for any reason. This, it will be a crisis, or application performance, it will be degradation, and so on. Then the cloud service provider, it will tell you, okay, Mr. Customer, I can guarantee that I will provide these resources for you, even if we have high demand on our resources. Well, this it can be configurable. This it can be configurable. This it will be considered as the minimum resources assigned by the cloud service provider to the cloud service user. Okay? Limits, it's totally different. What is limits? Limits, it will be the maximum resources it can be assigned to a cloud service customer from a cloud service provider resources. The limits, it will be the maximum resources it will be assigned to a cloud service customers from a cloud service user or customer, I mean. But there is a trick here, gentlemen. Let me ask you a question. Do you remember when we said that we have one of the features of the cloud that is dynamic scalable? This means that you have one server, as we mentioned, this is server number 1, but the application, we have high transactions. then we need to upgrade into 6 processor, then 8 processor. It depends upon the transaction. But if I will define the limits, if I will define limits, what will happen here? You will not be, suppose that I am saying you will be able to achieve only 6 processors or 5 servers at the same time, simultaneously. You will not be able to achieve anything more. Then, if my application requires this, I will be in a trouble. I will not be able to get it. Then I will lose the feature of dynamic scalability. When this limits does not mean anything for me. It may not be good for me. It may be bad. This is not what we are expecting from the cloud, that I have a dynamic, I can provision servers, provision resources. This is piece of cake. It will take only a few minutes and everything. It will be easy and I can have all my reservations. Then, if this is the case, why do you think that we need these limits? I want you to think about it.
No, we need these limits because suppose if a single thing, because of the concept of the multi-tenancy, because it is being shared among two tenants. So the thing is that there has to be a kind of a limit placed. Otherwise, what will happen is one particular tenant could utilize all the resources, and the other tenant will not get it. So that is why the cloud service provider puts a kind of a limit.
Okay, this one good reason. What else?
Because we have other module to implement like high availability, which we can use double of another additional resource with the same specs and everything.
No. We have other two reasons, gentlemen, which we are very important. One of the points which was highlighted by Prem. The second one, do you remember when I told you that the cloud service abuse, one of the threads? What is a
Yes.
cloud service abuse? That one VM, a hacker, he will get one VM and he will create one of, he will have his own tools, and these tools, it will create some processes and it requires more and more processor and memory, processor and memory, processor and memory, processor and memory. Then suddenly you will find that when the legitimate user try to access the additional resources, they will not be able because this machine it's consuming the resources. Then this is considered some way of denial of service. Then when the cloud service provider will define these limits, then this means that he will control even if there is any cloud hacker, he is trying to compromise the security or the resources, shared resources for the cloud service provider. This one of the reasons. Second reason, in some situation, and this is we found it as a practical from our experience. There is something called creepy usage. What is creepy usage? That now I want to create a server to test something, then I will provision the server and I will start work. Unfortunately, I will not delete it. I will forget to delete it. Then next time when I want to do anything else, I will create another server and I will do it. Then we found that the users, we will start to provision servers without any real needs. And we will forget to demolish these provisioning, to make the provision for them. Then we will find that the invoices pay as you use, it is come very high value, although they are not using. Then we will find that they reserve 5, 6 servers, although these servers are not used at all. But by the end of the day, they have the reservations, and these reservations mean that you have minimum resources. It should not be assigned to anyone else. and they will find that the pay as you go visit will be one of the problems. Then, if you will have the limits, and in the limit it mentions that you are allowed to have 10 maximum servers or 20 maximum servers, then this means that when the user he try to provision another service, he will not be able. Why? Because you reached the limit. Then you have to go and utilize one of your existing servers, which you did not deprovisioning, or you have to speak with the cloud service provider administrator or your account manager in the organization to increase the limits for you. Then this it will be the benefits of the limits, that pay as you go, use this, it would save some money for you, the creepy usage, the hackers, and so on. These are the reasons why we are still using the limits. The second concept, it will be the share. Second concept, it will be the share. What is the share? Share, this, it is considered as priority or importance. For example, let's say that the cloud service provider, we have a problem with the shared resources, and we have a limitation in the shared resources, and the users or the customers, they are trying to reserve some resources. These resources, it will go to whom? Of course, you can tell me first in, first out, that the first user you can, yes, we can, but we have something called the share. What is the share? This is a priority. Then if you have high priority than other user, high share as more than other user, you will be assigned the permission. Yani, for example, if we say that the cloud service customer 1 and cloud 2, this one he has share high than this, let's say 5, this 4, then this means that if there is a single 1 terabyte hard disk and they want to utilize it, then it will go to this one, even if they are choosing at the same time. Then this is what we call share. Very important to understand these concepts, because these concepts, you will find that there are a lot of questions in the exams related to these concepts. They are very important. Okay, the other thing is the storage. The storage. Of course, you remember we spoke about the storage before, and we mentioned that we have the different storage. We have the volume storage, and we have the object storage. What is the difference? Again, we mentioned that the volume storage and object storage, usually we are using in the ES model. Volume storage, it is used for structured. This one, the object, it is unstructured. In the volume storage, it is stored in form of pointers, and the volume storage, it will be the memory, the storage, it will be dedicated for the server. Server, you will see storage dedicated for it. Although it is a big storage, but it will be divided into something called LANs. This it called logical units, called LANs, logical units. They are slices of the storage, and each server, it will have its own slice. This slice, it can be 1 tera, 2 tera, 100 GB, whatever, and each one, it will see its own storage type.
Sir, what is the full abbreviation of LUN? Logical
unit. Logical unit.
Okay.
The object storage, it is totally different. The object storage, we don't have the concept of storing data and pointers and all this stuff, but we are, as we mentioned, we are used for unstructured data or discrete data. This can be files, it can be videos, it can be audios, whatever it is. And we are using to access a data. This data, it can be accessed by APIs, application program interface, or web interface. Can you give me an example of object storage?
S3 bucket.
Sorry?
S3 bucket.
No, I mean practical or commercial example of the object storage. Box.com, OneDrive, all these which you are using every day, it's an object storage. You are connecting what? You are storing what? You are usually storing files, discrete files. They are not related to each other. It can be video, it can be audio, it can be photo, it can be book, whatever. Also, you are access this through a web interface, or it may be an application. You can run it from iOS or you can run it from Google and so on. And this in the object storage, the accessing of the data, it will be very fast and it will be accessed used something called it's a unique value or a number. Unique value or a number. This it will be used to access the data. Then when you store a file, the file it will not be stored by its name. It will be stored by a unique value or a number, and this it will be faster in accessing this information from the storage. It is very important. It is very important. It is very important to know that the cloud service providers stores server images on object storage. This is one of exam questions. This is one of the exam questions. You have to understand very well this. You have to memorize it. This is very important. Okay? Okay. Okay. Just I want to remind you with this diagram because this it will be very important to understand where are we now. Now we mentioned that this is the model which you will have it for the cloud infrastructure components. As you can see here, we have the physical network. Then you have the network itself. Of course, we will say physical hardware and environment. This is a data center. Then the network, then the computing, and we spoke about already the storage. Then we will speak about the hypervisor. If we want to speak about the hypervisor, we mentioned that we have two different types of the hypervisor. We have hypervisor 1, we have hypervisor 2, and the difference is that in the type 1, it is more secure because the hypervisor, it will be installed on the bare metal direct without any operating system. The operating system, it will come over the hypervisor. In the type 2, it is vice versa, that the hypervisor, it will be installed on the operating system. Then if you have any bugs or problems in the operating system, then this means that it will affect your hypervisor. And usually the cloud service providers, they are using the type 1, we are using the type 1 hypervisor. Okay. Management plan. Management plan, this is very, very important. And I want you to understand this very well. Why? Management plan, gentlemen, you have to understand what is the management plan. What is the management plan? Management plan, this is the area where you are doing management for your infrastructure. doing management for your infrastructure. Create a user, provision a server, delete a server, change permission, adding resources to your servers, adding additional services as load balancer or whatever. When all these informations, whatever the management, this is the management plan for your all infrastructure. And in module number 1, I told you, gentlemen, whatever any exercises you are doing or administration, you are doing through what? You are doing through something called API, Application Program Interface. This application program interface is considered as an interface between you and the infrastructure of the cloud service provider. Then, if I want to create a server, the cloud service provider has the hardware here, and you are sitting here. Then you have some interface where you have to tell this interface, I want one server with specific resources. Then this it will go to the resources, create the server for you, and it will tell you, yes, it is ready. This means that this can be done through application program interface, or it can be done through web portal where you can access through the browser and so on. And this is where you are able to manage all your hosts and files, all your hosts and files. This it is very, very important. This is very, very important. And you have to understand that the management plans, it must have its own physical connection for the underlying hardware. What does we mean? This usually it is called OOB. Did you hear about this before? This is called out of band network. What is out-of-band network? Out-of-band network, gentlemen, you may have some devices here. This is a firewall, this another firewall. You maybe have another VPN. You may have a server. All of them are connected to the network, and users, they are accessing the data. If I want to make a management for these devices, as we mentioned, that the data traffic, it should not be merged in the same path with the management traffic. We will do a separate network, physical network. I will have one switch here, and I will connect the management interface of all these devices into this switch. And I will have one management server here where I can make all the configuration. As you can see that here, which are defined by the red circle, they are the data traffic. And the one which is highlighted in black, it is management. Then this means that for the management, you must have a dedicated physical connection. As you can see, all the devices which it's coming, it will have its own devices interface. It will management interface. It will have its own management interfaces, and this it's normal and it can be available, no problem. Then it is very important to understand this concept. At the management plan, it is very critical. This data, if it's leaked or if it's someone who was able to reach it, this it will be a real crisis. It will be a real crisis. He will be able to do anything on the cloud service provider. He will be able to do anything on the machines and so on. And this it will be a crisis for you and for the cloud service provider as well. Any questions?
So, sir, can we say the management plane as something like a console which controls, because it's quite sensitive, right? I think if an attacker actually attacks the management plane, that means everything is compromised, right?
Yes, this is a good question. Look, when we are saying console, usually we are when a console, it will be used when you will have a physical access to a machine. If you will have a physical access to machine, this is called that you are connecting your machine direct to a console board. Console board, it will open a command interface for you. This what we call it console, because you will find this console later in these next slides. But when we are saying management plan, then this means that it will be in a form of GUI and it can be accessed remotely without any physical connection. And of course, you don't have a physical connection with the devices of the cloud service provider, right? You don't have a physical connection, but still you are able to manage it. Why? Because you have the management plan, and this management plan, it is assigned in a form of API or portal or GUI.
So, sir, what is the usual API which is being used in management plane for interfacing with the infrastructure?
It depends, because when you will say API, application program interface, this means that you have some application or software which it want to communicate with the infrastructure of the cloud service provider. Then, as you will see later in module number 4, when we speak about API, we have two different types of APIs. It is REST and sorry. SOAP,
SOAP.
yes, REST and SOAP. And of course, REST, it is better because it's supporting security, caching, performance, so on. Then these are the types of the APIs which you can use.
Okay.
I think we deserve 10 minutes break because I don't want the data to be very concentrated on you. Let's have the 10 minutes and come back after the break. Okay?
Sure. Okay.
Okay, gentlemen. Now we will start another topic related to the data center design. The data center design, you have to understand that we have two different concepts. What are these concepts? The concept of the physical, and the logical. What is physical and logical? So simple like that. Physical, it is very physical. Logical, it is a virtualization. When you tell you logical, this means that the visualization. The physical, it is the physical, the actual servers and devices. Okay. As you can see in the this slide that we are speaking about the logical server. But if you don't mind, I like to start with the physical. It is better because the physical, it is the base where we are building the logical design of. Physical design, gentlemen, it is very important for a cloud service provider. Here, CCSP, we are considered you are a cloud service provider who is working with a cloud service provider, or you want to have your private cloud for your organization. Then they are saying where we can locate this solution, where we can locate the solution. Location, it is very important because you have to check many factors. For example, let me ask you a question, gentlemen. Which is better, to host a cloud service provider in Japan or in Saudi Arabia? And why?
So it depends.
Depends on what?
Depends on location.
Yeah, first is location and then the it is the laws and regulations.
Laws and regulations are valid in each location. It will not make any difference.
Definitely, I think if if I have to choose, I will choose probably Saudi Arabia. The reason being in Japan, there are a lot of earthquakes which happen. So
Yes, yes. This is the answer which I want to hear. You are right. There are a lot of earthquakes, which it can happen, and this it will create a disaster for you. Then this is very important to choose the location which it is far from the natural disasters. Don't host it in Japan. Don't host it in locations where you know there will be flooding or whatever. Don't host it in some countries where you know that political it is not stable and so on. Also, there is another factor we have to take it in our consideration. If we want to locate our data center location, this it must provide redundancy for external resources. What do you mean? Let me ask you a question. Which is better, to host your data center in Nigeria or in Saudi Arabia?
Again,
Saudi Arabia.
Saudi
Why?
Arabia.
Yeah, Nigeria is politically unstable as a country or location, so Saudi
Yes.
Arabia is better.
Yes, it is not stable. It is poor country. We don't have resources. Even the internet, it will be a single provider. And if it is not stable, this means that the service it will not be stable and users will not be able to reach to the services. But in Saudi Arabia, although in Nigeria, if there may be the cost or the investment, it will be less than Saudi Arabia. In Nigeria, the cost it can be less than in Saudi Arabia. And in Saudi Arabia, if the cost it will give cost me 1 million Saudi riyal, in Nigeria may cost 0.5 million only. But even if this is less, but this it will not make any difference for me because I will pay less. Okay, that's fine. But what about the internet connection? It's not stable, and users they are complaining that they are facing performance degradation and cut into connection and so on. Then they will drop the service at all, and they will move to another cloud service provider, and I will lose a market share. In Saudi Arabia, it's better. They have stability in political situation. We have multiple cloud service providers. We have multiple internet service providers, and so on. Then this it will be better for me. Then to choose the location, it has many factors. What about the facilities? What about the natural disasters? And all these information which it can affect my location. Okay, we have another thing, gentlemen, it's very important, called buy or build. Which is better? Let me ask you this question. Which is better? To build your own data center or to buy a ready data center?
I think depends on the industry, sir. If it is a very sensitive industry like healthcare and other things, I will have to. It is better to build a data center.
I don't
And
know if I am a cloud service provider. I don't know who will join me. It may be health, it may be normal users. I don't know. I am a cloud service provider. I will be public, for example.
So from a cloud service provider, then I think it's better to build.
Okay, we have some factors you have to think about it, pros and cons in it. If you choose the concept of build or buy, build it will be costly solution. If you will build, it will be costly, but buy it will be less expensive. Build, it will take time, but buy no time, because you will buy something available and you will be able to utilize it immediately. Build, you can make all your proper design. But in the buy, you have to accept the existing environment. I will not be able to make any changes. I will buy something which is already there. Then I mentioned that I need some white space. I need 1 kilometer square. I said, I am really sorry. In build, I can do it. Okay, but in environment, I am really sorry. This one, it is only 0.5 kilometer square. Then I will not be able to increase the space or whatever. Then these are the differences. It will be in the cost. It will be in the time. In build, it will take some time, 6 months, 1 year, 2 years, until the data center, it will be up and ready. It will be costly. You will have to bring investment, because when you will buy it, power, AC, all the data center cabinets and everything is there. But here in the build, you have to provide all these things. And also the build, you will be able to make your own proper design based on the recommendations and best practices for the infrastructure. Then whatever, build or buy, it depends upon your requirements, And there may be, you are in a business, you don't want to lose market share, then you will say, okay, I want to buy, then I want immediately to be available in the market, then I will not lose the market, and the customers, they may join with other cloud service providers. Okay, we will have another thing which is called environmental design. This is very important, gentlemen. This is very important, and I want to give you some numbers which I want you to memorize it. I want to give you some numbers which I want you to memorize. This is very important. I found some of these numbers in the exam. Myself, يعني. This is very important again. I want you to memorize it. I will write it to you, and I want you to memorize it. It should be between 64.4 to 80.6 degree Fahrenheit, or 18 to 27 degree centigrade. Humidity, 40 to 60%. I want you to memorize these numbers. I want you to memorize these numbers. I got some questions, and I knew from my trainees that they got questions about these numbers. Although this is a very simple question, very simple question, very simple question. You should not lose it. Okay?
I think Prem, you also got same question, right? Last time.
Okay. Multi-vendor pathway connectivity.
So,
As we mentioned before, gentlemen, that the multi-vendor pathway connectivity, this which we mentioned, the redundancy. And as we mentioned, if I want network connectivity as a cloud service provider, then it is better to do it in Saudi Arabia, because we have multiple cloud service providers. I can have 2 connections from 2 different cloud service providers. I can have 2 power sources, and so on. Then I must have a multi-vendor pathway connectivity. And note here, multi-vendor, because it's nonsense that you will take 2 internet connections from the same vendor. Because if his core service is down, then it will affect all the connections. Then we will speak about the logical design. The logical design, or which built on the virtualization. And of course, you are familiar with the virtualization now, where
Sir, can you please explain once more this multi-vendor pathway connectivity, please?
Multi-vendor pathway, this means that whatever any services you are getting, it should be from two different vendors, not from the same vendor. Then if you say that I have internet service provider, you must have a connection from internet service provider 1 and internet service provider 2. Why? Because if you took two connections or more from a single service provider and his core service is down, then this means that the whole connections, it will be down. Okay. Then we will have the logical design. Logical designs, we have the virtualization, which is the core of the cloud service, because this is where you are using the multi-tenancy. This you are using the multi-tenancy. We are using the multi-tenancy by getting one host. This host, you will have the hypervisor, then the operating system, and it can be divided into multiple VMs. Access control, as we mentioned, what is the access control? Mainly when we are speaking about access control, this will be the authentication and authorization. You have to work this very close with the cloud service provider, then you will be able to assign the right permissions for your users to access your data and applications. Also, you have the APIs, application program interfaces. These application program interfaces, it can be utilized and used in multi methods. There may be integration between your application on-prem and with the cloud service provider applications. And of course, this, if you want to have an interface between these two types of application, you need the API. Or you may need the APIs for the management plan. Then you will be able to manage your services, your data, and all this stuff. Then again, you need the APIs here. Then the APIs, this is a very important concept in the cloud service providers, because without the APIs, you will not be able to integrate applications, you will not be able to manage services, you will not be able to access resources, and so on. Then this, it will be very important for your service availability and service functionality as well. Data center resiliency, we spoke about this before, and we mentioned that this is very important for the data center, that you will have redundant components and a best practice data center where it can be able to support your infrastructure. Again, here, gentlemen, I think we are lucky because we have some standards which we can follow. Because if I tell you, please build your data center, you will tell me, what should I do? What is this required space? What the power requirements, AC requirements, the power, how can I provide multi-power outlet, all this stuff. Then here we are somehow lucky because we have some standards. We have some standards. What are these standards? We have 4 standards. We have 4 standards. Although we are familiar only with one standard of them, which is mainly used, but I will tell you the 4 because this you should know about them in CCSP exam. The first one, it is called building, industry, consultancy, consulting service, international. This is a standard, and it is created in 1977. It's created in 1977, and it is its number is ANSI PICSI 002-2014. It is not important to understand or to memorize this, of course not. And this standard, it's focused on the cabling design and setup, data center setup, cabling design and data center setup. Also, it includes specification about the power and the energy utilization. Then this one of the standard which you can use it, and it help you to give you the best practices for the cabling designs and the power and energy utilization. This is standard number 1. We have another standard called IDCA. It is more wider and it has more comprehensive data. It is International Data Center Authority. And this, it's considered as a framework for data center designs. And it will have an aspect for everything in data center design: cabling, location, utilities, security, connectivity, everything, physical security, everything. And this is again one of the really good framework, and also it includes the data center operations. And this is the only one which consider the operations here. Okay, this is the only one consider the operations. This the second standard. The third standard is called NFPA, and this is National Fire Protection Association. And this, it will have guidelines for safety, fire safety and design standards for fire. And also we have some documents, it's called 75 and 76, related to data center design. And there is another one. These two, they are related to fire protection of information technology equipment. This for 75 for protection the equipment against fires, and this protecting facilities against fires. You have another standard 70, which is for electrical code, how to design the electricity of the data center itself. Okay. The last one, and is the most popular standard which is used, the Uptime Institute. And this, gentlemen, it is the most well-known one. And we are divide the data center into tiers, 4 tiers. Tier 1, Tier 2, Tier 3, Tier 4. This is the least configuration. And this is the highest configuration. This, it has the redundancy for everything. Any component it will be added in the data center, it must be redundant when it considered the high performance. And what is it is based on the uptime period of the data center. Uptime of the period of the data center. How long? Because of course it's in 4. This means that we will tell you we are provide availability 999 5 times, for example. Then this will be considered high percentage of availability. Okay. Do you have to memorize this? Yes, you have. You have to understand at least the differences between all of them. This, it will be very important. You have to understand the differences between all of them. يعني, the information which you have it on the slides now, this is more than enough, which I write it to you on the whiteboard. This is enough. You don't have to read anything more. No, you don't have. But you have to memorize it, and you have to know it. You may find one of questions, and by the way, these questions, it will be very easy because we will not ask you about details. We will ask you about functionality, about objectives. In FBA, it will tell you data center, they want to have their own design for fire alarms when you know that it's in FBA and so on. Okay. Any questions? I think the next module, it will be risk assessment, and this it will be a very important topic. Of course, we will not be able to start now, especially we have only 5 minutes. Then I think we can stop now and do continue tomorrow. Any questions before terminating our session?
So, sir, on the Uptime Institute which you are taking, I think we didn't cover the differences between the tier 1, tier 2, tier 2, tier 3, and tier 4, right? That you'll cover it.
It is not. I don't think that it is covered in the course. In the course, it is not covered. We mentioned that it's only 4 tiers. If you need some more data about it, just check it. It is not a big issue, but in the CCSP material, it's not covered.
No, but I mean, so when I appeared, I saw 2 or 3 questions on the differences between tier 2.
Okay,
and
that's
tier
fine.
4.
Just you can get it from the Google. Yani, just check the models. It's not a big issue. This it will be only related to redundancy. Any other questions? Okay, then tomorrow we will start our session.